Alright, students, so today in fact we're going to be talking about erosion. Erosion is in fact a very unique and a very distinctive process which occurs throughout the entire world. It is in fact not restricted to any one geographical area, but occurs throughout the entire planet. Now, we'll get a better understanding of this a little bit later on in this particular video, but I'd like to focus on three important components. Now, apart from the definition, apart from what erosion is, we need to understand the agents which contribute to erosion. We need to understand the significance of erosion and also the four major processes of erosion. All right. Now, before we jump to the definition, in a previous video, we would have mentioned biological, physical, and chemical weathering. All right. Now, students, there is a big difference between weathering and erosion. Weathering does not involve a transport phase. It just involves the disintegration of rocks. But erosion refers to those said weathered materials or those fine particles or sediments which are subjected to movement or transport phases. For example, if you look at the screen here, all right, these little red little dots, all right, they represent particulates, or it could be dust, or it can actually be sediments. All right, and these are produced from weathered rocks. Now, students, weathering is completely different from erosion. Let us get that clear quickly, right? Now, erosion is a process whereby surface materials or sediments or particulates or dust, all right, being subjected to movement or transport phases by specific agents. And these agents can either be wind, water, or even ice. Alright, so if you look carefully on the screen, you will actually see these fine, unconsolidated, loose materials being subjected to winds. The wind speed and wind direction are extremely important to this. So we can actually say they are influenced by wind erosion. We can in fact bear in mind that this particular type of erosion or category of erosion is in fact quite pertinent to very dry or very arid environments. The reason why I'm saying this is because when the temperatures are in fact very hot, right, and the conditions are in fact very, very, very dry, all right, the concept or the process of physical weathering would be significant, which means that these rocks can be easily disintegrated, allowing their fine particulates to be subjected to movement, right, from one direction to another, depending upon the wind speed and also the wind direction. All right, keep that in mind for me. We also have erosion by water or flowing streams or flowing bodies of water. As you can see, rivers, which can traverse through the landscape, can transport materials given their specific unique flow direction. Even on the coast, as you can see on the screen here as well, these waves can batter these rocks and dislodge or loosen materials, thereby eroding them. Surface or ocean currents can also influence these particular type of sediment movements along the coast, as it could result in unique distinctive features as well. Like I said, surface as well as subsurface currents can contribute to water transporting loose, weathered, or loose, unconsolidated materials. All right, and the point with water, all right, we should also bear in mind that rainfall, a component in the hydrological cycle, a form of precipitation, can also transport sediments from one location to another. And given the fluvial movement and also the volume of water that is created because of these raindrops occurring on the surface of the land. All right. Also, bearing in mind that rainfall can in fact contribute to stream flow along rivers, and it can also help in terms of influencing the volume of water along the coastal environments as well. Okay. This image actually shows the influence of rainfall, right, on the surface of the land, especially areas which are associated with few or limited or little to even no vegetative cover, to where the land can be subjected to movement and even by some extension to some level of subsidence as time progresses. As you can see on the screen, these are what we call rills, which are created on the surface because of the flowing movement of water or rainfall, which creates a passageway on the surface of the land. All right. Rills can actually become very much more pronounced, especially given the fact that if you have a great volume of water, the land is subject to even more degree of instability these rills can become very, very deep. All right, and they are referred to as gullies. All right, as you can see on the screen here, this particular image and this little deep incision on the surface of the land influenced by rainfall as well. These are what we call gullies, which are primarily associated with rills becoming very, very pronounced by the significance of heavy rainfall and also a great volume of water traversing over the surface of the land. All right, apart from wind and apart from water, we know for sure even glacial melt, ice on the surfaces of large land masses can be associated with a significant amount of sediments being moved. All right, for example, during the warm periods, these ice structures or glaciers can be subjected to movement on a very, very slow basis, also transporting loose materials with them. This image actually shows here the elevation of the land, and obviously we can see on the upper regions here we have glaciers and ice structures being formed because of the elevation of the landmass. And also the temperature and whatnot will be greatly affected, will be greatly reduced because of the altitude. Now, the movement of the glaciers on the surface of the landmass can actually have a physical effect on the surface of rocks. For example, these rock structures at the base. I don't know if you could actually see my cursor here. These are what you call glacial striations, or striations refer to markings. And as ice and also solid rock structures grate against each other, right, because of the ice being subjected to movement, that would result in an edging effect, which actually, that meshing effect of those different solid rock structures on the surface of the landmass will actually allow the breaking away or the disintegration of the rocks, but also subjected to that transport phase given the direction of the glacier itself. So glacial movement can contribute to glacial striations, and those striations can also be influenced or related to, sorry, not really influenced, but related to erosion of particulates or components or pieces or structures of the rocks themselves. All right, let's go quickly into the processes of river. Well, I shouldn't say river, but I should say generally the process of erosion. There are in fact four major processes of erosion. The abbreviation is said to be CHAS. C is in fact referring to corrosion. All right, corrosion with an E. All right, refers to hydraulic action. E stands for attrition, and also S is solution. S is for solution. Sorry about that. So CHAS, CHAS is in fact the abbreviation. I usually tell people to remember it. Just remember these processes of erosion can actually occur in rivers. They can occur. They can also be associated with the coast as well, and they are also influenced largely by the agents themselves. All right, so it doesn't matter in terms of where it occurs, but just remember these processes are universal. Okay. All right, students. So let's look at this particular image very quickly, and we can see that corrosion is also known as abrasion. All right, and when something is said to have an abrasive effect, that simply means it tends to grate away or wear down on a particular object. Now, look at these two significant scenarios. We have on the screen here an area which is associated with arid or dry land masses, and winds can simply blow these fine particulates or these coarse particulates onto this existing rock. And as such, all right, the particulates themselves can actually come into direct contact with these rocks, and over a period of time can actually etch pieces of these rocks further away. So that means it will tend to grate or wear down this particular rock. So corrosion is in fact the process whereby surface materials are in fact grated or worn down, right, by the action of other particulates, which may in fact be relatively loose and be directed to that specific object. Okay. Look at the other side here. We are referring here to an environment which is associated more with water, and we can see fully well on the screen that we are referring to a riverbank. And by extension, we are talking about a cross-sectional area of a river channel. As you can see, the water is in fact flowing towards us, which is the screen. This section here, all right, it tends to have a kind of more eroded or cut off section. And the fact of the matter is that rivers will transport sediments or materials, and as they come into contact with this particular side, which is considered to be the concave bank of any given river channel, the force of the water is great, and these sediments will tend to undercut this side of the river. As you can see in this region here is largely eroded, as a matter of fact. It can happen to both sides of the river. All right, but as you go along the course of the river, you'll see mainly only one particular side, referring specifically to the concave bank of a river, is highly associated with this particular process of corrosion. All right, we'll talk about this a little bit further in a couple of videos ahead. All right, so then very quickly look at hydraulic action. The term hydraulic action is a process of erosion which is associated with the force of the water. And we know for sure, I have three major scenarios here. We have A, B, and C. A is in fact associated with a waterfall, right? As you can see, the great descent or the body of, or this drop, this vertical drop of water coming all the way down, it can automatically affect the integrity of rocks which may exist below and break them apart eventually. For scenario B, we have heavy or thunderstorm conditions, which can be associated with torrential rainfall, and as a result can contribute to a lot of flooding and a great volume of water traversing over the surface of the land. Also, C is in fact associated with what we call rough seas or rough waves. This can also be associated with tsunamis, storm surges, high tidal fluctuations, and stuff like that. And rough seas can contribute to battering of the land, and that is associated with a great degree of hydraulic force. Hence, the process or the concept of hydraulic action will be, in fact, very, very significant. All right, thirdly, let's talk about attrition. Attrition is, in fact, the process of erosion whereby rocks in the initial stages can be very, very rugged, and the edges can be very, very rugged, as a matter of fact. But after the process of attrition, we realize the rocks develop a smooth characteristic. Now, attrition is the process whereby the edges of the rocks become smoothened, all right, by constant bombardment or constant collision with existing particles and stuff like that. Okay, you can actually see the end result here. Look at the edges of these rocks are very, very smooth. All right, let me show you a quick image of that. Edges on these particular rocks are smooth here, and you can actually lick it. Now, I'm saying go and literally lick rocks, but the fact of the matter is that the edges become so smooth because they are constantly bombarded by existing particles which surround them. Okay, and coarse materials which eventually friction with them to smoothen the edges and whatnot. But not least, last but not least, let's talk about solution. Now we understand solution is a process of weathering, chemical weathering. Solution is also a process of erosion as well. If you look at it from a different perspective, rocks such as these may in fact contain minerals or soluble salts and minerals within their structures. All right, and if these particular rocks are in fact submerged, all right, underwater, sometimes these minerals and whatnot become dissolved into the surrounding body of water, and as a result, the rock can actually tend to become disintegrated, and by extension, the rocks somewhat become denatured, where they have little pockets or little holes and whatnot. All right, these minerals are said to be removed from that existing rock, and if there is in fact a surface current involved, assuming the water is going that way, all right, these minerals will be carried away, all right, from the origin, from the point of origin, which is this existing rock. Okay. Now, this image on the screen actually shows the effect of solution, whether we want to refer to the concept of weathering, but these same weathered materials can be subjected to movement eventually. And as you know fully well, the waves and water can actually carry these soluble minerals and salts, right, away from this particular rock elsewhere. This is something we really cannot see per se over existing period of time. We can actually see the effects of it. Students, we often hear erosion is associated more with negative things, but that is actually not true. Erosion is in fact very important in sculpting the landmass and creating different unique formations. For instance, we have lowest deposits which are in fact influenced by wind erosion primarily, where particulates and whatnot are blown over the landscape and deposited over a long period of time, eventually becoming consolidated. In addition to which, we can also have new landforms being created. For example, this tombolo, which is created whereby eroded materials are eventually redeposited in a specific sheltered location. We also have erosion, which is very important in terms of the nutrient cycling, primarily in aquatic or even marine ecosystems, where winds can actually deposit, or even water can actually deposit materials from one location to another. And these particular particulates may, in fact, contain nutrients in them, which is very, very important in the nutrient cycle, biogeochemical cycles. The same could be applicable to terrestrial ecosystems as well. For example, dust from the Sahara can actually blow from Africa all the way across the Atlantic and even help in fertilizing the rainforest in South America, which actually is very, very important, which harbors a great diversity of species. All right, so students, I hope this was actually very beneficial. Any questions, feel free to let me know. All right, y'all keep good.